So now you've got a complete seal scanner with the camera and the projector really accurately aligned, all ready to go. I'm now going to talk about scanning a seal. Again, I'm not going to say anything about the software. For one thing, it'll depend on which edition of the software you've got in the end, and for another, it's quite fiddly to show on the video. So there's separate instructions for the software. I'm concerned mainly with this hardware. And to scan a seal, we need a seal. Here's a seal I made earlier. The original of this is in Paris. This is a replica made by scanning the original seal on this equipment and then making a digital model and then 3D printing that model. And this seal works. You can roll it out and see a nice impression of the figures on it. And the digital model shows a great deal of detail on it. To mount it, you take off the alignment object, which was on earlier, and you replace it with one of these mats. This one with the little pimples is good. There's also a smoother one with without pimples, but just circles. Seal obviously goes centrally. You can use the circles to align it as well as you can. And then if the seal's got a hole, you can just drop the same cap that we used for the alignment object into the hole, and that'll keep it nice and central at the top. If your seal doesn't have a hole, or a good central hole, and many of them don't, you need to replace this conical cap with one of these caps, and you do that simply by pulling that out, and then you can just sort of put that there and lower the bearing onto it and push it in. And you should choose a cap that's just a little bit smaller than the seal, if possible. Well, you've got 3 sizes, so it'll always be possible. So go for one that's close to or slightly smaller than the seal. So if this didn't have a hole, I'd be using this tiny cap on top of it, like that. It does have a hole, so put it as centrally as possible. If the seal's broken, try and line it up so that the original axis of the seal, the original axis of the cylinder, lies at the centre of the turntable and the centre of the top bearing. That can be pretty awkward and fiddly, but we have actually managed to scan some really quite broken seals with jagged parts at the top and bottom, so it is possible. Get it as central as possible, and we'll finish off lining it up with using the camera view to check that it's accurate. So here's a view of the seal on the screen, and at this stage you're asked to draw a rectangle round the seal so that the system knows where it is. You could try and guess, but it's more accurate if you do it. And you do that just by dragging a rectangle round it. Make the rectangle you draw tight. Don't leave a margin. It'll automatically leave a margin and then show you what it's got. It's good to draw the rectangle tight because that's used to estimate make a rough initial estimate anyway of the seal size. When you've done that, you can check from different angles that it's central. So here I'm turning it through 90 degrees, and we can just check that it stays in view. If it goes out of view or looks like it's no longer, or looks like it's well off central, then you need to adjust the position and just make it as accurate as you can. And you can do that repeatedly, but if it's a tiny bit off, it doesn't matter too much as long as it stays in the frame while it rotates. At this stage, if it's hard to see, don't worry if it's bright or dark. That can get sorted out a bit later. Also at this point, you'll be asked to enter the institution name and the acquisition number, or whatever the institution uses for the seal. For the institution name, you should use something that corresponds to the URL of the institution's main website. For the seal name, you should make it as close as you can to the catalogue number in the institution's official catalogue. We spent quite a lot of time reworking the numbers of seals from one or two places to try and make them correspond to the official lists. So try and get that accurate. It's easier if you can do that first time. You need now to focus the camera and then the projector. In both cases, you do it with the knob on the translation stage. You don't change the focus on the lens of the camera or projector. So to focus the camera, it would be this knob and the equivalent one on the projector mounting. So here's the view of the screen, and if at this point you can make it brighter or darker to try and make the picture clearer. This is a highly magnified view of the shadow edge on the seal, and I'm making it a bit darker so that I can see some of the detail. And then what I have to do is to focus the camera by moving it with the stage until that's as crisp as possible. This can be tricky on some surfaces. It's not great on the plastic that the seal's made of. It's also a lot easier on some seals. But if you look at the detail here, for example, you can see that I can get it quite crisp and sharp, pixels sort of glittering like little spots. And that's focusing the camera. To focus the projector, what I want to do is to focus it, is to move it so that the shadow edge is as sharp as possible. This is very tricky in some cases, but you can see that at this point, if I move it a long way off, this shadow edge goes quite fuzzy. It's just a gentle transition from bright to dark. And if I move it back towards a focused position, it'll gradually become sharper. But it is sometimes quite hard to see when it's exactly at its sharpest. I've just gone slightly past. That's about sharp as it goes. As I say, it's quite tricky on this material that the seal's made of because it's a bit translucent. It's equally difficult on translucent stone, but if you have a problem, I'm about to show you a way around it. So just to recap, the camera you're moving to focus the detail on the surface, the actual little bits of sparkly material or the markings on the surface. Again, much easier on some surfaces than others. That's pretty sharp now. The projector, you're moving to try and make that line between the illuminated part and the shadow as sharp as possible. If you've been able to focus the camera, but you're really not sure if you've got the projector focused correctly, there's a little cheat you can do. If you look at the side of the camera, there's a scale on it there, and you can see you can use the right-hand side of this metal part to read off the zeros 3mm, in this case the right of it. If you set up the projector to be the same, again using the equivalent knob and moving it so that the zero just shows the same distance to the right of the metal plate, then it'll be pretty accurately correct. So if it's not easy to focus visually, just do it that way. It's helpful for future processing of the images if you put a piece of dark card behind the seal. That can just stay there now for the duration. It just makes it easier to pick out the outline against it. If you have an extremely dark seal made of almost black stone, then it's worth just using a piece of white card instead. Again, just to provide contrast. But the plain background, and normally a black plain background, is very helpful. We're almost ready for a scan, but for that to work well, it's got to be dark. So there's a light box that you can put over the equipment to block out the room light. You might want to consider making a better box than this. This is getting a bit battered and old. It's just held together with these brass clips that get pushed through the foam card material. And there's a little hole here and you position that over the rod at the top of the seal mount just to make sure it doesn't touch it. There's also a gap at this side, and if you're neat with the wires you can bring the wires out through that gap and it sits down neatly on the base plate all around the rest. So that makes it dark inside. It means that the final thing to do is to adjust the camera exposure so that the image is the right brightness for each of the scans that is going to be done. For that final brightness check, here's the screen view. You can see the seal, there's the line of the shadow, and you can adjust the brightness so that you get what seems to be the best contrast across it. So I'm going to make that a little darker, in fact, because it's completely whited out here, but it's not as dark as it might be there. This is a bit subjective, and also takes a moment for it to respond. Just set that a little darker still. That seems reasonable. I'm going to go back a bit brighter, actually. There we are. That's about as good as I can do on this difficult material of the plastic seal, but you can see that I've got quite good contrast there across the shadow line. And once I'm happy with that, I can start the scan. You can see the seal now rotating and being scanned. This is the point at which you mustn't jiggle the table. It'll take a couple of minutes to do this. It looks jerky in the display, but it's not actually. The movement's smooth, and what's recorded to disk is smooth. It's just that that's the priority over displaying it on the screen. So you'll sometimes see it freeze and jerk, but you don't need to worry about that. What you do need to worry about is to be sure that the shadow line stays in view for the whole rotation. If it doesn't, you need to recenter the seal and repeat. And also that both the top cap here and the bottom are moving with the seal. When you can see things moving, they should all move together. There shouldn't be any slipping at either end. If the seal slips, it does spoil the results quite severely. So keep an eye on that and make sure that as the seal goes round, the top cap does too. You normally do 2 scans with the box in place. The first one is the one that we just saw starting. When that's finished, you'll hear the turntable stop, and you switch over from the line projector to that general LED and do another scan that's generally quite a lot quicker, just with the LED on. And what that gives you is the unwrapping, the surface appearance of the seal, whereas the first scan was about getting the 3D structure and creating a 3D model. When the second one's finished, for the second one I should say, you adjust the brightness again, the exposure rather, just to get a nice appearance, just to the position where you can see as much detail as possible. When that's over, you switch off the LED to avoid dazzling yourself. You can take off the box, and to finish off, I won't demonstrate this in detail, but to finish off you have the opportunity to take another 2 or 3 pictures, well, as many as you wish, of the seal at different orientations. You can position it so that there's a particular feature towards the camera if you wish to, and it'll take as many images as you want with the angles equally spread through the round the circle. And that's often done under general room illumination rather than with the LED on, so that you have a diffuse light, and that can be clearer and a better image, a better general image of the surface, for example, for making fat cross composites, than with the LED, where you tend to get highlights and reflections. When you've done those, you have the opportunity to do the ends of the seal. This is generally quicker than doing them separately, with a camera, and also makes it much more consistent and easy to build fat cross composites. And you do that simply by turning the seal on its side and putting it under the cap like that. And you do the bottom end first, and then you turn it over and do the top end. You have the opportunity to focus the camera for each of those in case it hasn't gone down in quite the right position. And that's it. You've completed a seal. They get a lot faster to do as you go along. You don't have to do all the fiddly setting up all the time, though you do have to refocus the camera and projector for each seal. When you've finished, do switch the turntable off so that it can do its powering down thing, and then you can hopefully leave the system set up for your next session. Good luck.